Bum, ba-da-da, da, 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 da. I need theme music. That's what's lacking in these videos. I don't have any theme music. All right, here we go. Sorry for the shaking. Normal distributions. Okay. Last video we talked about measures of central tendency, the mean, median, and mode, and the measures of distribution, the range, and the standard deviation. Okay, so now let's look at this a little more carefully. In your textbook, this is page 757, they have this image. Okay, but I'm going to explain you everything here about the normal curve and the areas under a normal curve. Most data that we deal with in our reality of our lives will fit pretty close to a normal distribution. That's why it's called normal. Okay. It's often called the bell curve because of its shape. It's shaped sort of like a bell, an old-fashioned bell, with this being the clapper here. Okay. Now, in its normal distribution, it's called normal because things are standardized. The first thing you need to know about a normal distribution is that general shape, and that, as you notice, it's more data is in the middle than towards the ends. Okay. And our x bar, our mean, is right at the middle. Everything is related to the mean, just like when you're doing your standard deviations. You have to take each value from your data set, subtract the mean from it to figure out which side of the mean it's going to lie. So as you see in this diagram, we have sigma minus sigma. Okay, so here's this region here is the first standard deviation below the mean. Okay? And this would be the first standard deviation above the mean. Okay? And that percentage of your data in between the first standard deviation below the mean and the first standard deviation above the mean will encompass approximately 68% of your data is going to come in there. 68% of people in the world are within the first, either below or above standard deviation, say in terms of height or wealth or intelligence. That's normal. Okay? If you go beyond that to the second standard deviation above and below, I'll squeeze in a little bit so you can see it. Okay? Second standard deviation above and second standard deviation below. Okay? You can see now we're encompassing almost everybody. That's 95% of your data is going to be between the second standard deviation below the mean and the second standard deviation above the mean. So that doesn't leave very much for this region here between the second and third standard deviation. Okay? But as you can see, once you get to the third standard deviation, you've got almost 100% of your data. It's just a little bit more, there's always those people who are way out there, either way far above the mean or way far below the mean. Okay? But 99.7% of your data is going to be between the third standard deviation below the mean and the third standard deviation above the mean. Then there's some outlying, way far out there kind of stuff. Okay? Let's look at that a different way. Okay? And this is how it's going to relate to what you're going to do, and you're going to relate it to your probabilities. We think about, say, this region here from the mean to the first standard deviation. That encompasses about 34% of your data. The same with from the mean to the first standard deviation below the mean. That's about 34% of your data. So let's look at these other regions. Okay? This region here that's between the first standard deviation and the second standard deviation would be 13.5% of your data is in this region. Okay? And then getting to that far out there, 2 to 3 standard deviations, you're down to just 2.35% of your data. And then beyond that, there's not much left. There's only 0.15% left for that region beyond the third standard deviation, that 0.15%. So remember those numbers, 13.5, 2.35, and 0.15, and of course the 34. So we can use those as sort of a way of dealing with probabilities. Okay? So we can say, like, what's the probability in a data set, in general, in a data set, what's the probability that the value you choose is going to be less than, say, 1 standard deviation below the mean? That's what this symbology is saying. That our value that we want is going to be somehow less than 1 standard deviation below the mean. So we look at our data, we say, well, okay, well, here's the 1 standard deviation below the mean. And we're talking about being less than that. So that means we have that 13.5% plus that 2.35% plus that 0.15%. If you add that all together, you get 16%, or as a decimal, 0.16 is our probability. Probability of finding something, a number, of randomly selecting a number out of all these numbers that's going to be in this region below the first standard deviation is 16%. We could do similar ones. You could say, what's the probability of it being between, let's say, probability of it being, of our number between, so that our x is, let's see, x minus 1 standard deviation is less than the x is less than x bar plus a standard deviation. Okay. So you can see that that region is this region in here. Okay. And this region here is 34 plus 34, and so that probability is 68%, or 0.06, 0.68. Okay, so that's using the distribution table. Now let's go one more step forward. Let's put some actual numbers on there. Let's say you had some data, and you had a normal distributed data set such that the average, the mean, is equal to 33, and your standard deviation is, say, I don't know, do I want to use the one in the book? Standard deviation is 4. Okay, so we can set up our distribution curve. Whoa, a little carried away there. It's telling us that our x bar is 33, that our first standard deviation is 33 plus 4, second standard deviation would be 37 plus 4, third standard deviation would be 41 plus 4. Okay, and then the other way around, 33 minus 4 is 29, and 29 minus 4 is 25, and 25 minus 4 is 21. Okay, so what's the probability of a number being between 29 and 37? Okay, so a number between 29 and 37, p of your value being between 9 is less than x is less than 37. Let's make it equal to make it easier. Okay. So 29 to 37 inclusive. Well, this is that central part of your distribution curve. Okay, so that's 34% here, 34% there. So that makes it probability equals 68%, 0.68. Okay. What's the probability of a number greater than 41? That our number, that x, probability of x is greater than 41. Okay. We look at this and say, whoa, this is my 13.5 part, and this is my 2.35 part, and my 0.5 part. So I got 2.35%, 3.5, plus that 0.15%, which makes 3%. Or as a decimal, 0.03. Okay. So that's how you can use your distribution curve, remembering those percentages. Okay. And these percentages, if you don't trust me, you can also look in your textbook. That's page 757. For that distribution curve and those percents, but that's what you're going to find in there. And that's how you would use those exercises. Okay. So there you go. There's something for you to do, and I'll post this up there and give you the assignments I want you to do, and we'll be done with this by the end of next week. All right, take care, guys.